Welcome to EDU World Space.
This question asks us to consider the molecule A2X4, and it tells us that A and X are elements, and the AA bond length is represented by D1, and the AX bond length is represented by D2. Part A, it asks us, in terms of D1 and D2, how would you define the bonding atomic radius of atoms A and X? So I've written this here as radius of A and radius of X. And then at B, it asks us to describe a different molecule. So we'll do part A first. So the bonding atomic radius of A can be looked at just in the AA bond here. When you have two atoms forming a bond, the bond radius is simply half of the bond length. So if D1 is the entire bond length, half of this bond length, or the atomic radius of one atom, comes from half of D1, and the other half comes from the other atom. So that makes the bonding atomic radius of atom A 1/2 of D1. Again, half of this distance comes from one of these elements, and the other half comes from the other element, and that distance is simply the radius, or the bonding radius of that element. So bonding radius A is 1/2 D1. Now what is the bonding radius of X? We know that this entire distance D2 comes in part from the bonding radius of A and in part from the bonding radius of X. We know the bonding radius of A because we just found it here. It's 1/2 D1. So that means that the rest of this bond length comes from bonding radius of X. So the bonding radius of X has to be D2 minus the bonding radius of A. If we write that out, that's D2 minus 1/2 D1. So this is how you express Rx for just using terms D2 and D1. So this is part A. And part B says, if we were to imagine a molecule X2, how can we express its bond length? Just like when we were considering the bond length here between two A elements, the bond length would be simply twice the bonding radius of one of the elements. So what we solve for here, if the bonding radius of A was 1/2 D1, then the bond length would be twice that, or D1, which makes sense, which is what we had in part A. So bond length for an X2 molecule would be 2 times bond radius of X. And we can just plug in what we had here. This would be 2 times D2 minus 1/2 D1. So this is how you would express the bond length of an X2 molecule using terms D1 and D2.